coming to the units lipid. Lipid is any compound which is insoluble in the water and soluble in the non-polar organic solvent. So this is a lipid which is basically a non-polar. But if you see a fatty acid, now the difference between fatty acid and lipid is that fatty acid is polar. So fatty acid is COOH carboxylic acid, and if you remove one H ion it becomes COO negative. So since we know that it is a charged particle, it is ionized, that is why it is a polar compound. Now all the fatty acid are represented by word acyl. So if you see word acyl anywhere, that means it is a fatty acid. Now don't get confused between the word acyl and acetyl. So acetyl CoA is something which we have studied in the link reaction. Now this is acyl. Acyl is the word that is given to a nickname for the fatty acid. So fatty acid, which is a polar compound, which combines with the alcohol, that means OH, the words that ends with ol, which combines, so fatty acid combines with the alcohol and it forms a non-polar compound, that is fat, or you can say ester or the lipids. So all are non-polar. So if you see a compound that is a fatty acid, suppose this is a fatty acid which contains carboxylic acid, which combines with a group that is an alcohol. So it forms a compound that is known as fat. So we remove water, H from carboxylic acid, OH from alcohol, water is removed in this reaction and we get RCOO R2. This is a ester bond and this compound is known as a fat or a lipid, which is a non-polar compound. So the fat is a non-polar compound, it has got a ester bond, while on the other hand a fatty acid, it is a polar compound which combines with alcohol to form the fats. Now if you see fats, that is a lipid. As I told you, it is combination of, a lipid is a combination of a fatty acid plus alcohol. This is the basic composition of a lipid or fat. So a simple lipid is which is formed by combination of fatty acid and alcohol. A complex lipid on the other hand, it composed of fatty acid, alcohol and some other component. Now this component can be either phosphate or carbohydrate. If it is a phosphate, it is known as phospholipid. If it is carbohydrate, it is known as glycolipid. Now if it is phospho, as the name suggests, phosphate group and a lipid group, and if it contains carbohydrate, it is one carbohydrate compound and a lipid compound. So since phosphate is a polar, lipid is a non-polar, so that makes this compound as amphipathic compound. Now glyco is a polar, a carbohydrate is a polar compound, and lipid is a non-polar compound, and glycolipid also makes it amphipathic compound. Now let's go to the lipids, simple lipids first. A simple lipid is formed by a fatty acid and the alcohol. Now the alcohol in most of the cases is the glycerol. If you draw the structure of glycerol, it is CH2OH, one is H, then we have CHOH and CH2OH. So this is the structure of glycerol, which is the basic alcohol that is present in the simple lipid. So most of the simple lipid contains the alcohol in form of glycerol. This is the structure of glycerol. So in simple words, if I have to draw this structure, I can just draw a letter E, which represent these carbon and hydrogen, and I can add OH group to it. So this is a structure of a glycerol, which I'm going to make the simpler form of glycerol. So the glycerol structure is OH, OH2, 3 carbon. Now monoacyl glycerol, as the name suggests, now we are talking about simple lipids. That means there are two components to it. One is the fatty acid, another is the alcohol. Alcohol in this case, we are going to take glycerol, and fatty acid, let's talk about. So the term fatty acid, there is a nickname to the term fatty acid, that is known as acyl. Monoacyl means there is only one fatty acid that is attached to glycerol. So just draw a simple structure of glycerol, that is OH, OH and OH, and to one we add a fatty acid. So basically this is a ester bond that is formed between alcohol and the fatty acid, and this is known as monoacyl glycerol. Now as the name suggests, monoacyl means there is only one fatty acid and a glycerol. So a ester bond is present between a fatty acid. Now this fatty acid component is the polar part, and the lipid in general, it is non-polar. So this OH here is polar OH here is polar, and this fatty acid, when it combines with OH, that makes it a non-polar. So this fatty acid, when it combines with the OH, that makes it a non-polar, because this is a lipid structure. So this is fatty acid. When it combines with alcohol, it makes it a lipid, and that is why it is a non-polar. So non-polar, polar and polar. So basically, if you see monoacyl glycerol, that is an amphipathic molecule in which one fatty acid is attached to glycerol. Diacyl, as the name suggests, di means two, acyl means fatty acid. So there are two fatty acids in a glycerol. Let's draw the structure of glycerol first and then attach two fatty acids to it. This is fatty acid 1, fatty acid 2. So if you see, fatty acid and alcohol is a non-polar. Fatty acid and alcohol is a non-polar, and only OH is a polar. So diacyl glycerol is also amphipathic molecule. Triacyl glycerol, tri means 3, acyl means fatty acid, glycerol is 3OH, that is attached to the carbon chain. So this is fatty acid 1, fatty acid 2 and fatty acid 3, 3 fatty acids attached, known as triacyl glycerol. So triacyl glycerol is a structure which is also known as triglyceride, which is basically the storage form of fat. So the storage form of fat in the body is in triglyceride. So triglyceride is basically a triacyl glycerol. And if you see, there are 3 fatty acids attached to it, all are non-polar. That will make this triacyl glycerol as the non-polar, and that is why triacyl glycerol, which is also known as triglyceride, these are neutral fats because it is a non-polar. So 3 fatty acids attached to the glycerol. Now coming to the structure, phospholipids. This is a complex. Now this, up till now, this is the simple lipids. Now talking about the complex lipid. In complex lipid, if phosphate group is attached to the lipid, it is known as phospholipid. If carbohydrate group is attached to a lipid, it is known as glycolipid. Now if you recall, the phospholipid and the glycolipid, these are the 2 complex lipid. Now talking about phospholipid first. That means one alcohol and fatty acid is just a lipid, and when the phosphate group is attached to the lipid, it is known as phospholipid. So if you have a look at the structure, one fatty acid is attached to alcohol, another is attached to alcohol, but the third alcohol group, you can see a phosphate group is attached to this alcohol, right? So this particular component is known as phosphatidic acid, in which there are 2 fatty acids attached to glycerol, and the third unit of glycerol is phosphate group. Now this phosphate group is always attached to a side base. Side base can either be a choline or it can be ethanolamine. If the side base is choline, then this kind of structure is seen in case of lecithin. Lecithin is, we have studied in the physiology, which is a lung surfactant. So L for lecithin and L for lung surfactant. Now ethanolamine is a cephalene which is present in the CNS, which is C for cephalene and C for CNS. So if they ask you the product of hydrolysis, that means break down that product. If they ask about lecithin, so lecithin is composed of 1 choline. Let's go from here to there. So from backwards, 1 choline, 1 base and 1 phosphatidic acid. In the phosphatidic acid, we have 2 fatty acids, 1 glycerol, and we have 1 phosphate group. So this is the structure of, these are the products of hydrolysis of lecithin. So if they ask about cephalene, hydrolysis of cephalene product gives 1 ethanolamine, 1 base, 1 phosphatidic acid. In the phosphatidic acid, we have 2 fatty acids, 1 phosphate group, right, and 1 glycerol. So they can ask questions like this. Now coming to phospholipases. So phospholipases, these ases, right? These are the enzymes that break the phospholipid, right? As the name suggests, phospholipid, these are the enzymes that break the phospholipid. So you have to draw a structure of a phospholipid. In the phospholipid, it is lipid plus a phosphate group. And in a lipid, we have fatty acids plus alcohol. In the alcohol part, we have 1 glycerol, right? So we can draw fatty acid, glycerol plus phosphate, and so this is a phosphatidic acid. So this is OH, fatty acid, OH, fatty acid, OH, phosphate group, and to this phosphate group, base is attached. Now base can be either choline or ethanolamine. So phospholipase enzyme break the phospholipid. It can break into several places. So A1 is one that breaks first fatty acid to glycerol. A2 is that breaks the second fatty acid to glycerol. Then C is that breaks this diacyl glycerol. If you see this structure, if you break this, we get this diacyl, that means 2 fatty acid and 1 glycerol to the phosphate and base part. And if you break at this point, then we get a phosphatidic acid. This one is the phosphatidic acid and 1 base. Now coming to cardiolipin. Cardiolipin is a complex phospholipid, and cardiolipin is a glycerol that is attached to 2 phosphatidic acid. Now a phosphatidic acid structure is this one. We have a phosphatidic acid structure. This is phosphate group attached to the phosphatidic acid. So this is one phosphatidic acid, and we have 2 phosphatidic acids attached to glycerol. This structure is known as cardiolipin. So cardiolipin is present in the inner mitochondrial membrane, and because of this complexity of the structure, cardiolipin can be antigenic also. Now phospholipid, if you see, if the phospholipid is glycerophospholipid, that means the alcohol is glycerol. Up till now we have talked about parent alcohol as glycerol. But if the parent alcohol is sphingosine, then the phospholipid is known as sphingophospholipid. Now let's draw the structure of sphingosine. Sphingosine is, let's draw a simple structure of glycerol first. In sphingosine, the second OH group is replaced by amine group, and we have up till C20. So this is the basic structure of a sphingosine. In some books it is written up to C18. So it is unsaturated 20 carbon amino alcohol. Some books again it is carbon 18 it is written. So it is OH. Now if you see sphingosine, this is a alcohol, and this alcohol when attached to the phosphate fatty acid, it becomes a lipid, and this lipid is our ceramide. So if you see, this is a sphingosine OH up till the carbon 20. If you attach one fatty acid to it, and this is known as sphingosine when attached fatty acid, this is known as ceramide. And this bond between fatty acid and NH is CONH. This is our bond that is present in the lipid. Now sphingomyelin is, if you attach a phosphate group and choline to it, then it becomes sphingomyelin. So this is the amide bond that is present. So sphingophospholipid is alcohol plus fatty acid plus phosphate group. We have a syndrome that is associated with cardiolipin, that is known as Barth syndrome. In case of Barth syndrome, there is a defect in cardiolipin remodeling. Coming to polyunsaturated fatty acids, these polyunsaturated fatty acids have more than or equal to 2 double bonds. Since these polyunsaturated fatty acids are essential in diet, therefore they are known as essential fatty acids. So polyunsaturated fatty acid have got 2 or more than 2 double bonds. If you draw a structure, we have carboxylic acid at one end, and we have multiple carbon atoms attached to it. In the other end we have a methyl group. So one is the carboxylic acid end, another one is the methyl end. Carboxylic acid end is known as carboxy end. Methyl group is known as methyl end. So if you place a double bond in between here, and if you start counting from carboxy end, then that make it first carbon atom, second carbon atom, third carbon atom, fourth carbon atom. So here you can see that methyl group is attached to the third carbon atom. This is known as delta system. So this is delta 3. If you start counting from the methyl end, so if this is a methyl end, then first, second, third and fourth. So if you place a double bond here, that will make it omega. This is a omega system, and that makes it a omega 3. So this is delta 4 and omega 3. So depending on which side you start counting the double bond, we have this kind of system. Omega system is the most accepted system, and you must have heard of omega 3 fatty acids. So this is the double bond that is present at the third omega group, that is taken from the methyl end. So if the carbon double bond is taken towards the methyl end, it is known as the omega system. Now we have two categories in the omega, either omega 3 category or omega 6 category. So omega 3 category, we have savonic acid, which is also known as DHA. Now you must have heard of the term DHA. DHA is docosa hexa and hexanic acid. So docosa hexanic acid. Docosa word means that 22 carbons. 22. Docosa word means 22. Hexa means 6. And En, that means a double bond. So this docosa hexanic acid, that is a DHA, it is composed of 22 carbon atoms and 6 double bonds are present in this DHA, which is known as savonic acid. So this DHA, all the health drink are fortified with this DHA because breast milk contain DHA, and for a child early growth we need a DHA for the early growth of brain. So it requires brain development for the first 2 to 3 years of life, and that is why Bonvita and all these contains, they add DHA to it so that they can give it to the children small, first, second, third year of age, so that brain development of the child occurs. So this is first omega 3, which is known as savonic acid. Now all the acid that we will be talking about, either it is alpha linolenic acid, alpha linolenic acid, gamma linolenic acid, or linoleic acid. All the fatty acids that start with L, they have got 18 carbon. So alpha linolenic acid means it has got 18 carbon, and linolenic, it contains a longer word, so it contains 3 double bond, and linoleic, so linolenic is a bigger one. Linolenic is three double bonds. Linoleic is 2 double bonds. So linoleic is 18 carbon atom and 2 double bond, and linolenic is 18 carbon atom and 3 double bond. Now the difference between alpha linolenic and gamma linolenic is that the position of double bonds are different. So alpha linolenic contains 18 carbon atom and 3 double bonds, and it is an essential fatty acid. It is precursor of omega 3 category. That means if a person takes alpha linolenic acid, he can make DHA also and make timonidonic acid also. So basically it is a precursor of omega 3 fatty acid. Timonidonic acid contains 20 carbon atom and 5 double bonds. Now coming to omega 6 category. Omega 6 category is gamma linolenic acid. Gamma linolenic. So linolenic means 18 carbon atom and it contains 3 double bond. Linoleic means it is a shorter word and it contains 2 double bond. So linoleic acid contains 2 double bond. It is a 18 carbon atom and it is the most essential fatty acid. So if they ask most essential fatty acid, it is linoleic acid, which is a shorter word, and that is why 2 double bonds are present. It is precursor of omega 6. So linoleic is precursor of omega 6. It can synthesize arachidonic acid and gamma linolenic acid. Linoleic is the most essential fatty acid. Arachidonic acid is 20 carbon atom and there are 4 double bonds that are present. It is important for the synthesis of prostaglandins and leukotrienes. Now you can get question like C17H31COH formula is of which? Now if you have a look at the structure, it is, first of all, understand this, in a saturated fatty acid the hydrogens are double in number that of carbon atom. For example, if carbon atom are 2, then hydrogen are going to be 4. So, and this is one thing, hydrogen are going to be twice the number of carbon atoms. So hydrogen is equal to twice the number of carbon atom for a saturated fatty acid. Now if you make double bond, then 2 hydrogens are lost to make 1 double bond. So if there are 2 double bonds, that means 4 hydrogens are less. Now if you have a look at the structure, which is C17H31COH. So how many carbon are there? 17 carbon at this and 1 is in COH, that is an acid. So there are 18 carbon and hydrogen 31 and 132. So there are 32 hydrogen. Now if you see a saturated structure of this, that will become double the number of carbon, so hydrogen will become 36 for the saturated structure. Now if you see how many hydrogen are less, there are 4 hydrogen less, so that makes it 4 hydrogen, makes it 2 double bond. So in this structure, this is 18 carbon atom structure with a 2 double bond. Now if you recall all the omega 3 and omega 6 category, 18 carbon atom means starts from L. Now either it is a linoleic or it is linolenic. Linolenic is the bigger term which consists of 3 double bonds, and linoleic is the shorter one which consists of 2 double bonds. Now if you can recall, 2 double bonds is of linoleic acid, which is the most essential fatty acid. So this formula is of linoleic acid, which is the most essential fatty acid. And remember one more point, omega 3 category is a cardioprotective category. It affects the fluidity of the membrane. It gives signaling across the membrane, and its metabolites are anti-inflammatory. That is why it has got a cardioprotective role. So omega 3 fatty acid, very important in the diet. So essential fatty acid, that is alpha linoleic acid, and linolenic acid is the most essential fatty acid. Then examples of mono unsaturated fatty acids. So they are oleic acid. This is a omega 9. Then allidic acid. This is omega 9 again, and palmitoic acid. Palmitoic acid, which is a omega 7. So which of the following is not essential fatty acid? Oleic acid is not essential fatty acid. Lipotropic factors, they prevent fatty liver. They are inositol, betaine, methionine, choline, androgens, growth hormone, casein, and lecithin. This was the monounsaturated fatty acid. Now talking about polyunsaturated fatty acid. These are the essential fatty acids. So PUFA is polyunsaturated fatty acid. It can be omega 3 or omega 6. So examples for omega 3 category, it is DHA, which is a fish oil, and this DHA is a 22 carbon compound, and it has got 6 double bonds. Then we have alpha linoleic acid. Alpha linolenic, alpha it is linolenic acid, and this is 18 carbon having 3 double bonds. Then we have the omega 3 under omega 3 category, timnodonic acid. Timnodonic acid is a 20 carbon compound with 5 double bond. Now alpha linolenic acid is the flaxseed oil or the soya bean oil, while timnodonic acid, it is the fish oil. So fish oil, we have DHA, which is cervonic acid or DHA. It is omega 3. Now coming to omega 6. In omega 6 we have gamma linolenic acid. This is omega. So we have gamma linolenic acid. Gamma linolenic acid is an 18 carbon compound, and it has got 3 double bonds. This is the oil of evening primrose. Then in the omega 6 category, linoleic acid. Guys, linoleic acid is the most essential fatty acid. So which is the most essential among all these? Or they can ask you about exception based question, which of the following except is essential fatty acid. Remember, linoleic acid is very important. It is the most essential fatty acid. Linoleic acid is a 18 carbon with having 2 double bonds, and it is a safflower oil. Then we have arachidonic acid, which is a 20 carbon compound having 4 double bonds. This is arachidonic acid is present in the animal fats. So if I ask you the most essential fatty acid, it is linoleic acid. It forms the amino acids and leukotrienes. So most essential fatty acid is linoleic acid. Linoleic acid, it is a safflower oil, 18 carbon compound, 2 double bonds.